So in this next section, section 1.4, we're going to use the definition of trig functions that we talked about in section 1.3. We're going to use them to derive other formulas and look at other features of angles and the trig functions themselves. Okay, so the first thing is just a quick review. When we defined trig functions, we looked at a triangle that was set on the x-axis, okay? And the angle, theta, is the one at the origin. The horizontal side is the x value of the point up here on the right, and the vertical side is the y value, okay? The hypotenuse is labeled as r, or radius, okay? Now, when we defined the three trig functions, we used this abbreviation SOHCAHTOA, okay? We have the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent, okay? And we talked about that in the last section. And so when I look at this triangle, theta is down here towards the origin, so x is the adjacent side, y is the opposite side, and r is the hypotenuse. And so when I set up my three fractions, I'm going to start with the sine of theta is the opposite, which is y, over the hypotenuse, which is r. So y over r, okay? And then the cosine is adjacent over hypotenuse, so that's x over r. The tangent, oh, I'm missing something. Learn from me, this was a big mistake actually. I did not put a theta with this cosine, I did put a theta with this sine. You always have to have an angle with your trig function, okay? So, must have an angle there. We're going to call it theta. That's the typical variable that we use, although later in the course we'll change it up from time to time. Okay, so you must have an angle there because these functions are defined based upon the angle, and with different angles you get different function values, okay? So cosine theta is x over r, and the tangent of theta is opposite over adjacent, which is y over x. Okay. Okay, now, and then we said the other three trig functions are the reciprocals of these. And so the secant's reciprocal is the cosecant, or I'm sorry, the sine's reciprocal is the cosecant, which is then r over y. The reciprocal of the cosine is the secant, which is then r over x. And the reciprocal of the tangent, we call it the cotangent, which was x over y. Okay, those are all the reciprocals. Now, because of these definitions, the way they're written, these are all the possible combinations of sides of the triangle, okay? But because of these definitions, we have what we call reciprocal identities. So a trig identity is just an equation that relates two different expressions of trig functions. And so if the sine and the cosecant are reciprocals of each other, then we can write them as one over the other. Okay, and so let's switch color here. So the sine of theta is actually 1 over the cosecant of theta. Okay, so they're reciprocals. And of course, you could switch those. You could say the cosecant is 1 over the sine. In a similar way, the cosine of theta is 1 over the secant of theta. Okay. And we have the tangent of theta is 1 over the cotangent of theta, okay? So again, we call these identities because they identify two different expressions of trig functions as identically equal to each other, okay? Now, some interesting things occur when this theta, when this angle, moves to other quadrants, okay? In the first quadrant, everything is positive, right? The x is positive, the y is positive, and the r, being the radius, is always positive. But when the theta moves to quadrants 2, 3, and 4, the sign changes on x and y. And so, because the sign changes, some become negative, some are positive, the sign of the function changes, okay? So when you plug in a negative number in for the y, for instance, you end up with a negative value for the fraction, okay? And so let me summarize that for just a moment. In quadrant 1, we know in quadrant 1 that all three are positive. So x is positive, greater than 0, y is positive, and r is positive, all of them, okay? Well, as a result, these ratios, and I'm just going to focus on the top 3 for right now because the reciprocal will have the same sign, okay? SIGN. So there's two different signs I'm talking about. There's the SIN function, and then there's the sign positive negative, which is spelled SIGN. Try to keep straight which one's which based upon the context of what I'm talking about. So the sign of the sign would be whether this sign is positive or negative, if that makes sense. Okay, anyway, it's confusing sometimes, but we'll try to work through it. So quadrant 1, the sine of theta is going to be a positive number because we've got a positive divided by a positive. Okay, so it's greater than 0. Same with the cosine, because we'll have a positive x and a positive r, right? Both of those are positive. Oh, not equal, it's going to be greater. And same with the tangent, because the x and the y are both positive, okay? And of course, when we take the reciprocal of a positive, you get a positive, so all of those other 3 functions are positive. Now, if we move to the next quadrant, let's take a look at quadrant 2. Okay. In quadrant 2, the x value becomes negative, right? So you're looking at the x and y axes here. In quadrant 2, x is negative, but y is positive because you're going left and up from the origin. Okay, so x is negative, y is positive, and r is always going to be positive because it's a radius. Okay, and so with these 3 signs, we can identify the sign of the 3 trig functions. So sine theta, well, the sign of the sine is going to be, well, we've got a positive over a positive, right? Y over r is positive over positive, makes that positive. The cosine is going to be, well, x over r is a negative over a positive. Negative over a positive is negative. Oops. So this is going to be less than 0. And the tangent of theta, remember tangent is y over x, and so y over x, that's going to be, going back here, positive over negative, which also makes a negative, okay? So interestingly, in quadrant 1, all 3 trig functions are positive, but in quadrant 2, only the sine is positive, okay? And of course, correspondingly, the cosecant. But cosine, tangent, all the other ones are negative. Okay, let's now take a look at quadrant 3. We'll start running out of room here. Now we'll just go down to the bottom. Quadrant 3. Well, in Quadrant 3, you're going to be down here in the lower left, and in the lower left, the x is negative and the y is negative, okay? Both are negative. So I'd have x less than 0, y is less than 0, and r, the radius, again, is positive. And so when I identify the sign of the three trig functions, sine of theta is going to be a negative over a positive, right? Y is negative, so that's negative. Negative divided by a positive. The cosine is going to be, let's see, let me count it. The cosine of theta is negative over positive as well, so that's a negative. And the tangent, well, the tangent is y over x, which is a negative over a negative. A double negative makes a positive, actually. So this, oops, keep it equal. This one is going to be positive because of the double negative. So in this case, in Quadrant 3, the tangent is the only one that's positive. Okay. Now, let's take a look at Quadrant 4 for a moment. Get rid of this line up on top. And let's go with this. So, Quadrant 4. It's going to look a little bit out of order, but that's okay. I'm just trying to summarize some things here. So Quadrant 4 is on the lower right of my axes, and in the lower right, the x is going to be positive because it's to the right, and the y is negative because you're going down. So x is positive, y is negative, r is always positive. And so my three trig functions then, the three main ones, sine theta, well, the sine is y over r, so it's going to be positive over positive, that's positive. The cosine is going to be x over r, which is, oh, did I just do that wrong? I pointed at the wrong thing, I think. Sorry, the sine was y over r, which is a negative over a positive. I did, which is negative. Sorry about that. Okay. The cosine is x over r, which is positive over positive. And so that'll make a positive value. And the tangent is, let's see, tangent is y over x, which in this case is a negative over a positive. See, I keep going to the wrong line. Negative over a positive, which is negative. Okay, so of the three trig functions here, cosine is the only one positive. Okay, so when I look at all four quadrants now, I can identify which sine or which trig function is positive, and then all the other ones are negative. Okay, so in the first quadrant, all three were positive. They're all greater than 0, right? In the second quadrant, only the sine. Third quadrant, only the tangent. And in the fourth quadrant, only the cosine. All right? So I'm going to make a quick summary, a little chart over here, a diagram. If you draw quick XY axes over here, then in each of those quadrants, I'm going to write a letter representing what trig functions are positive. So in the first quadrant, all of them are positive, right? In the second quadrant, only, what did we say? Only the sine. In the third quadrant, only the tangent. And in the fourth quadrant, only the cosine. Okay? So this ASTC, going around in the order of the quadrants, represents the the functions that are positive in that quadrant, when the angle is in that quadrant. Some people remember this by an abbreviation. All students take calculus, which of course isn't true necessarily, but that's all some people remember. There's other ones too, there's other ways to remember it. I don't remember all of them, but I always remember all students take calculus because that's what I learned. But ASTC going around, okay? It's going to be very important for you to know this when it comes to test time, and really throughout the course we're going to refer back to this diagram very regularly, okay? All right, so now let's take a look at some other applications of the trig functions, or some other identities. So in this triangle, we know that the Pythagorean theorem holds because it's a right triangle, okay? So we know that x squared plus y squared must equal r squared. It's Pythagorean theorem applied to the x, y, and r rather than what you normally see a, b, and c. Okay, so this is Pythagorean theorem. And what's interesting is if you were to divide each of these terms by r squared, oh, maybe I'll do that in a different color, just so it stands out. So let's divide each one, r squared, and r squared. Okay. So I can divide by r squared, and what you end up with is x over r, y over r, and r over r. Well, the r squared over r squared is 1, right? Anything divided by itself is 1. But x over r, remember, is the cosine, right? And y over r is the sine. And so x squared over r squared is the cosine squared, cosine theta squared, right? Because x over r is cosine, so if you square both of them, you're squaring the cosine. And the y squared over r squared is the sine squared. So I'm running out of space. Let me rewrite that a little bit. It's going to be plus the sine of theta squared equals 1. Now we have a shorthand way of writing the square of a sine and a cosine because we don't always want to put these parentheses. We'll end up getting some really weird looking expressions when we have these parentheses in here. And so an easier way to write this is just to say the cosine squared of theta. We tack the square on the cosine. It doesn't really matter where it is. Essentially, you calculate the cosine and then square that value. So we say the cosine squared plus the sine squared is equal to 1. This is what we call the Pythagorean identity. Okay. And it is true for any angle. Okay. It's called the Pythagorean identity because it comes from the Pythagorean theorem. Okay, now we could repeat this process starting with the x squared plus y squared equals r squared. And we could divide by x squared and then divide by y squared. Okay, so repeat the process with an x squared on the bottom, and then repeat the process again with a y squared on the bottom, and then simplify. And what you'll get are 2 more Pythagorean identities utilizing the other 4 trig functions. Rather than writing all the details out, I'm just going to show you what those identities then become. Okay, they are going to be the tangent squared plus 1 is equal to the secant squared Okay, so that's one of them. The other one is 1 plus the cotangent squared is equal to the cosecant squared. Okay, so those are the other two Pythagorean identities. So we have really three Pythagorean identities. I'll put a little red star next to them. Right there, and right there. Those three identities. Okay. We can also build a relationship between the sine, cosine, and tangent. Because we know that the sine of theta is y over r, cosine theta is x over r, and the tangent of theta is y over x. So these three fractions we know are true, and so I can set up a relationship between them. Notice that if I were to divide the sine of theta by the cosine of theta, then essentially what I have on top is y over r, and on the bottom I have x over r. And with fractions, remember, if you have a complex fraction like this, fraction inside of a fraction, you can multiply by the reciprocal of the bottom. And so you end up with y over r times r over x, right? The x over r flips. And then the the r's cancel out, and you're left with just y over x. Well, y over x, we know, is the tangent. So we found an expression that's exactly equal to the tangent of theta, namely sine over cosine. So anytime you're dividing the sine by the cosine, you can replace that with the tangent. It just simplifies things. Okay? Okay. Good. So in the next video, we will take a look at some applications and some problems that we can solve because of these identities.